Hi, everybody, it's Mrs. Pound, and we are starting a new chapter, chapter 6.2 on sound. So, the first thing we have to talk about are sound waves themselves in section 621. So, our objectives for today's video are to rank the mediums that transmit sound the best and describe the two factors that affect the speed of sound. So, what is sound? Actually, sound is a great creation of God because we really depend on sound a lot, isn't it? Well, sound is a mechanical disturbance produced by an object's vibration. So, if we look in the background here, what I mean by mechanical disturbance is we actually have to pluck those springs, so it is strings, excuse me, so it is mechanical, and the strings vibrate, and those produce sound waves from the guitar. Now, a sound wave is a longitudinal wave. Remember our slinky? This is not a transverse wave that goes up and down. This is the longitudinal wave that is parallel, and where we squeeze the springs together and let them go, and it runs back and forth along the slinky. That's the kind of wave we're talking about here. Now, sound waves travel across a room when two people talk to one another. How they do this is the vibrations from one person's vocal cords transfer energy to surrounding air molecules. So we have the woman in the background speaking. And when the air molecules collide with one another, they transfer the energy until the wave arrives at the second person's ear. Right there, she's listening. Now remember, it is a transfer of energy. The molecules that start out at the first woman's vocal cords do not reach the second woman's ear. Okay? It is different molecules, but the energy has been passed to them. Now, the dense energy regions of a sound wave, remember, are called compressions. So, where the springs are really close together, those are compressions. Where they're farther apart, those are rarefactions. Sound waves travel at different speeds through different mediums. We had talked about this when we talked about waves. They travel fastest through solids and then through liquids and slowest through a gas. And we talked about how Native Americans would put their ears on the ground and they could hear horses coming through the ground, the solid ground, before they could hear them through the air. The same thing as you could put your ear on a train track and you can hear the train coming faster through the track than you can through the air. And so I have the door knocker on the back to remind you that sound travels faster through the solid door than it will through the air. Now, in space, sound cannot be heard because it requires a medium. There's no air there or anything in space to transfer the sound waves, to transfer the energy. So next to this statement, draw a circle, write sound in it, and put a slash mark through it, like no sound. Okay, there is no sound in space. So these astronauts, they cannot just talk to one another. They have to communicate through radio communication. Now, radio waves do not require a medium to travel through space because they're not the same thing as sound waves. They actually are electromagnetic waves, which are a form really of light. However, underwater, sound can be heard because liquid is a medium. Remember, and it also, the sound will travel faster through the water than it will through air. Now, other than the type of medium, another factor that affects the speed of sound is temperature. Okay, temperature affects the speed of sound. So we have medium that affects the speed of sound, and we also have temperature. Warmer temperatures add energy to particles, and this causes them to move faster and have more collisions. Energy is transferred faster when particles collide. So if a room is warmer, sound waves will travel faster. If it cools down, they will travel slower. Now, it's not too noticeable. It's not like you're going to notice an extreme difference, but it does happen. So, our objectives for today were to rank the mediums that transmit sound the best and describe the two factors that affect the speed of sound. Don't forget your 5 questions, and I'll be back with more about sound.